equations of motion. Anybody remember how we started deriving the other one? We started with our definition of acceleration. So in this case, we should start with our definition of angular acceleration. So suppose we have a particle that's moving around in a circle with angular acceleration alpha, with angular velocity omega, and time t. It starts at time t0, which I'm going to define as 0, and any time t is what I'm looking for. So these are my boundary conditions. So may I start with my definition of alpha, which is angular acceleration, defined as d omega over dt. May I write alpha dt equals d omega? For all of our cases, are our accelerations constant? They are just a number, right? So then may I just integrate and integrate from some 0 to some t and from some omega naught to some omega? So then may I write alpha t equals omega minus omega naught, or omega equals omega naught plus alpha t? Does that not remarkably look like something we have seen before? For the linear case, which we called equation 1. Okay, wonderful. Now we can use this equation to get equation 2. I know omega is d phi over dt equals omega naught plus alpha t. Now, is omega naught a constant? It's just a number, right? The boundary condition told us what it was. It's just a number. Is alpha a constant? It's just a number. So may I then write d phi equals omega naught dt plus alpha t dt? May I integrate? That means you should do this in 2 steps. I'm going to just cheat. Can I write this? Omega naught is a number. Alpha is a number. Just comes out. Okay. That means from some phi 0 to some phi, from 0 to t, and from 0 to t. Are those our limits of integration? Means I will get phi minus phi naught equals omega naught t plus 1/2 alpha t squared. Or delta phi equals omega naught t plus 1/2 alpha t squared. Does that not remarkably remind you of something?
Yeah, okay.
We've seen this before, right?
Yeah, that's the second equation.
That's the second equation. Yay! Okay, now for the third equation, we know alpha equals d omega over dt. Can I multiply and divide by, may I rewrite this as d omega over d phi dot d phi over dt? What is this? Omega? Then that means I can rewrite this as alpha equals that, or alpha d phi equals omega d omega. And then I can integrate again from some phi 0 to some phi, from omega 0 to omega. Will I get alpha phi minus phi 0 equals omega squared over 2 from omega naught to omega, or alpha d phi 2 equals omega squared minus omega naught squared? Is that not remarkably like equation number 3? Now I can make a smiley face.